Today, we're diving headfirst into one of the deepest, weirdest mysteries in all of science, the quantum world, and the strange, almost spooky role that we seem to play in it. Now, physicists have been banging their heads against this wall for about a century. But what if the key to solving it wasn't in some futuristic physics lab, but hidden in a philosophy book that's almost 400 years old?
Okay, let's just get right to the heart of it with this one question. It's like this. On one hand, you have the universe as this shimmering cloud of pure potential. And on the other, you have the solid, definite reality that you and I experience every single day. So what's the trigger? What makes it go from one to the other? The answer, and this is the bizarre part, seems to be us, just looking.
So here's our roadmap for today. We're going to start with the quantum enigma itself. Then we're going to trace its roots back to what you could call a philosophical crime scene. We'll see how science completely hit a wall, and then we'll explore a radical vision that might just stitch our reality back together again. All right, first things first, let's get a really solid grip on the problem itself. It's famously known as the measurement problem, and believe me, this isn't just some minor little quirk. It's a massive, foundational paradox right at the very heart of how we understand what's real. So check this out. This slide really shows you the two different faces of quantum reality. Before we look, a particle is just a wave function. You can think of it as a cloud of pure potential. It could be here, it could be there, it could be everywhere all at once. But the instant we measure it, bam, that whole cloud of possibilities just vanishes, and the particle snaps into one single actual location. The potential becomes real. So here's the thing. Physics is fantastic at describing the before, the cloud of potential, and the after, the actual particle. But what it absolutely cannot explain is the transition itself. What even is a measurement? How does the simple act of looking at something trigger such a profound reality-altering event? That's the measurement problem.
Now, to understand why science is so completely stuck on this, we actually have to go back in time. And I mean way back. We're leaving the 20th century physics lab and traveling all the way back to the 17th century. Because the roots of this scientific puzzle are, believe it or not, philosophical.
The key culprit here has a fancy name, the Cartesian bifurcation. But you can just think of it like this. The philosopher, René Descartes, took a giant philosophical knife and just sliced reality clean in two. He created two totally separate, non-overlapping domains that have defined the way we think ever since. So he created these two worlds. On one side, you have res extensa. This is the physical universe, seen as a giant, cold, lifeless machine. It's made of pure data, just matter and motion. In this world, things like color or beauty, they don't really exist out there. Then, on the other side, you have res cogitans. This is the world in here. It's the internal world of the mind, consciousness, thoughts, feelings. And for Descartes, these two realms were totally separate. They never, ever touched. And you know what? For classical physics like Newton's, this split was an absolute game changer. It was a gift. By deciding to just ignore all that messy, subjective mind stuff, science could focus exclusively on the measurable, predictable machine of the universe. And it worked. I mean, it worked beautifully for hundreds of years. The basic assumption was simple. The physical world is the real deal, and our experience is just kind of a faded echo happening inside our heads.
But, and you knew a but was coming, this incredibly successful idea, this bifurcation, it crashes head-on into quantum mechanics. The very key that unlocked the classical cosmos becomes a kind of philosophical prison.
And here is exactly where the old model just completely falls apart. I mean, think about it. If reality is only the objective physical machine Descartes described, then an observer, you, me, a scientist, is also just a part of that machine. So when a quantum system gets measured, where does that collapse from potential to actual come from? A machine can't just decide reality. This leads to a really absurd paradox. It's called the von Neumann chain. If everything is just a physical machine, then the particle's quantum weirdness should basically be contagious. It should infect everything it touches. So the measuring device itself enters superposition, then the computer screen it's attached to, then the light from the screen hitting the scientist's eye, and then even the scientist's brain cells. The superposition just grows and grows forever. You never get a single real outcome. It's an infinite regress into absurdity. So here's the paradox in a nutshell. The entire philosophical foundation of modern science, this idea of a purely objective world, it literally has no place for the very observer that quantum mechanics tells us is absolutely essential to make reality concrete. The framework itself is creating the problem.
So, if the framework is the problem, what's the solution? Well, let's look at a pretty radical idea from physicist Wolfgang Smith. He basically says, stop trying to solve the puzzle inside this broken box. Instead, let's just break the box. He wants to heal that 400-year-old cut in reality.
Smith argues that the fundamental mistake we've been making all along is that we've confused two very different levels of reality, which he calls the physical and the corporeal. We've just been acting like they're the same thing, and according to him, that's the source of all this confusion.
Okay, so Smith makes this really critical distinction. The physical realm isn't the world we see and touch, not at all. It's the quantum world, the realm of pure potentiality, the raw mathematical stuff of the universe. The corporeal realm, on the other hand, that is the world of our everyday experience, the world of solid tables, red roses, and actual things.
Now, with this new picture, the so-called collapse isn't some weird physical process happening down in the machinery. It's the moment of actualization. It's the bridge that connects the potential to the actual. And the toll to cross that bridge is an act of observation.
So this shows the new flow of reality. You start with the physical realm, this wave of pure possibility. Then a conscious observer performs an act of perception. And that act pulls forth a single concrete reality into the corporeal realm. Now, the observer doesn't create reality out of nothing, but they are the necessary catalyst for it to actually appear.
Okay, so what happens if we actually accept this? What if we heal that old split in reality? Well, the implications they're profound. They change not just physics, but our entire understanding of the cosmos and our place in it. This unified vision basically rewrites the rulebook. It reunites the observer with the observed. It brings things like color and texture back into the real world. It introduces a whole new kind of cause and effect, and it poses a powerful challenge to the idea that science alone can explain everything.
You see, classical science only really recognizes what we could call horizontal causation, one billiard ball hitting another, all happening on the same level of reality. Smith's model brings back this idea of vertical causation, where a higher level of reality acts upon a lower one. In this view, the conscious mind, operating from a higher plane, acts on the lower plane of physical potential to actualize it.
And this changes everything about our experience. In the old scientific model, the color red isn't really in the rose. It's just a certain wavelength of light that your brain processes and interprets as red. But in Smith's view, no. The redness is a real, genuine feature of the rose, one that's brought into being when an object and a subject meet. Qualities are real again.
Ultimately, what this all amounts to is a powerful critique of scientism. That's the belief that physics can give us a complete description of reality. Smith is arguing that, no, physics was only ever designed to study the world's quantitative skeleton, its mathematical substratum. That weirdness you see in quantum mechanics, it isn't a sign that reality is weird. It's a sign that physics has finally reached the limits of its own map.
And this is the thought I really want to leave you with. In its quest to create a purely objective picture of the universe, did science actually succeed in describing reality? Or did it just create a beautiful, mathematically precise shadow of a much richer, deeper, and more integrated cosmos? A cosmos that we are not separate from, but are, in fact, fundamental participants in bringing to light.